So methods of lighting calculation. So there are many methods for lighting calculation. Among some of the methods among them are watts per square meter method, uh, and lumens or light flux method, or a power point to point method. So watts per square meter method is a rough calculation method to determine the illumination required in a room. Okay, in a room, or it can be even an outdoor space also. It depends. Okay, so depending on the area of the outdoor space that is to be illuminated, you can do some rough calculations and by this method, by watt per square method. Okay, so in this method, watt per square meters of area is illuminated. That's all. Roughly you will calculate. No specific calculating formula is not there for in this method. Okay, whereas in the next method, that is lumen or light flux method, in this method, whenever we want uniform illumination over a work plane, okay, then we will go for light flux method. Okay, so for we have to calculate the illumination required in a so and so work plane, and it can be a room. Okay, so we will prefer all the sources which will produce uniform illumination. Okay, or average illumination if I want. Okay, average means uniform only, nothing else. Okay. So whenever I want an average value of illumination on a in an area that is to be illuminated, okay. So I will prefer this method. In this method, you can calculate the total lumens received on the work plane by this formula. So what you require in this method is you need to know the number of lamps, and you need to know the wattage of each lamp and efficiency of each lamp in terms of lumens per watt, coefficient of utilization, and maintenance factor. So if you know all these terms, values of all these terms, then you can determine the total lumens required on the work plane. Next method is point to point method. So in point to point method, you can even call it as inverse square law method. So whenever I want to illuminate a particular point using several number of sources, okay, whose candle powers are known, then I will prefer this method. So there is an empirical formula to determine the illumination required. Okay, so actually the formula is n is equal to the number of lumens required is equal to the area into illumination by utilization factor into the flux, luminous flux into maintenance factor. So from this formula, you can determine the required illumination. Okay, so these are the three methods by usually used to determine the required illumination. So let us solve some problems on this. We have already solved this in the last class, so I'm not going to discuss about this problem. We'll go for the next problem. Okay, so in this problem, if you see, it is so it is a drawing hall in an engineering college, which is to be illuminated. So you want to install some lamps in a drawing hall, and this hall dimensions are given. The length of the hall is 30 meters. The width of the hall is 20 meters, and height of the hall is 8 meters. So the length, breadth, and height of the room has been given, and you must mount the lamps at a height of 5 meters, and the level required for illumination is 144 lumens per meter square. I hope you people are writing this problem in your notes. All of you, as I'm talking, you people write it down in your notes. So here we are going to use metal filament lamps, and we have to estimate the size and number of single lamp luminaries, and also we have to draw their spacing layout. Okay, and utilization factor is given, that is 0.6, and maintenance factor is 75, and space height ratio is given, that is 1. Lumens per watt are given, that is 300 watt lamps. Sorry, lumens per watt for 300 watt lamp is given, that is 13, and lumens per watt for 500 lamp is given, that is 16. Did you complete writing? As soon as you complete, you just type C. Make it fast, all of you. I'm going to check your notes today. So make it fast. As soon as you complete writing this question, just type C. Did you complete? Make it fast, all of you. Is there anyone who is writing? Did you complete? Okay, just type C, that is more than enough. Okay, don't type all the alphabets of complete word. You just type C, that is more than enough. Okay, ma. Now, so we this is the given data. Okay, now the dimensions of the room are given. So what is the area of the room? Area is, the area to be illuminated is the surface of the room mostly. Okay, so the area that is to be illuminated is the length and breadth. Okay, so area to be illuminated, write down all of you. Area to be illuminated, A is equal to 30 into 20. So what is the value? Can anybody type 30 into 20? Area? Area to be illuminated, 30 into 20. What is the value? Okay, anyhow, I will show you, leave it. Okay, you people are taking much more time. Even if I discuss anything, I think you won't be able to uh, follow me. I don't know. Okay, so area to be eliminated. A is equal to the length into breadth. Okay, so 30 into 20, you will get 600 meters square. Okay, so illumination required is given, E is equal to 144 lumens per meter square. Illumination required is given already. So the total flux required for illumination is area into illumination. Okay, phi equal to. Okay, so this is the required phi. Okay, so but this phi, that's why I have not written phi here. Why? Because if I write phi in two places, you may get confused. Okay, the number of lumens required is A into E. So area is 600 into 144. You will get 8644, 86400 lumens. Okay, so utilization factor is given, that is 0.6. Maintenance factor is 0.75. So the lumens required, phi equal to what? A into E by utilization factor into maintenance factor. What is A value? A is A into E. Already you have determined A into E. What is it? 86400. Okay, utilization factor is 0.6 and the maintenance factor is 0.75. You will get 192,000 lumens. Okay, this is the required lumens. So initially you have to determine the area to be illuminated, and you have to multiply area to be illuminated with the illumination to get the lumens required, total lumens required, and utilization, depending on the utilization factor and maintenance factor, you have to determine the lumens required. Okay, this is the lumens required without considering utilization factor and maintenance factor. But we know utilization factor and maintenance factor plays an important role. Something is wrong with my system? No. Okay, so utilization factor and maintenance factor. So this flux, this lumens is without considering utilization and maintenance. This lumens is considering utilization factor and maintenance factor. Did you complete this slide? Type C if you have completed. Make it faster, ma. If you are responding quickly, I can proceed. Very good. Next. So they have given lumens per watt for 500 watts lamp, that is 16, and they have also given lumens per watt for 300 watts lamp, that is 13. So multiply lumens per watt with number of wattage of the lamp, lumens per watt with wattage of the lamp. So if you multiply lumens per watt with lumens per watt, that is 16 for 500. If you see the question, if you have written in your notes, you can see. Okay, for 500 watt lamp, lumens per watt is 16. For 300 watt lamp, lumens per watt is 13. Okay. So you have determined lumen output for 500 watt is 500 into 16. Lumen output for per 300 watt lamp is 300 into 13. Okay, so 500 into 16 you will get 8,000, and 300 into 13 you are getting 3,900. Okay, and number of 500 watt lamps required. Okay, number of 500 watt lamps required is given by the lumens required by lumen output. Okay, so lumens required you have already calculated, that is 192,000. Okay, so 192,000 by 8,000, you will get 24. So the number of lamps required for 500 watt lamps of 500 watt lamps. Okay, okay, so for 500 wattage, okay, the number of lamps required of 500 wattage is 24, and the number of lamps required of 300 wattage is what? Lumens required by the lumen output per 300 watt lamp, that is 3,900. Okay, so it is 192,000 by 3900 is nothing but 49. So the number of lamp required of 300 watts are 49. Number of lamp required of 500 watts are 24. Okay, so now your room dimensions are 30 meters into 20 meters. The area to be illuminated is 30 into 20. Okay, so you have to check. So how many lamps? Of course, lamps you have already calculated. Of 300 watt you need 49. Of 500 watt you need 24. So which wattage is preferable for you? You have to decide. Okay, it's in your hand. Okay, so you have to do on your own, on your own thinking, because here manually there is no specific formula to calculate to decide. Okay, so if I am considering 300 watts lamps, I'm sorry, 500 wattage lamps. Okay, then what I have found is, since I need 24 lamps, okay, so if I am using 4 rows of 6 lamps, okay, so 4 into 6 is 24, and I will get a spacing of 5 meters both in width and length of the hall. Okay, so how this 5 meters is obtained is, the length of the lamp is 30 by 6. Okay, you will get 5 meters. Width of the lamp is 20, so 20 by 4, I am getting 5 meters. So for the given space height ratio of unity, Okay, so I think 500 watts lamp is preferable when compared to 300 watts lamp. So for the given space height ratio of unity 1, okay, so these 300 watt lamps are, we cannot use 300 watts lamps for the given hall dimensions of 30 into 20. Okay, so did you complete this slide? So I need 4 rows and in each row I will place 6 lamps. In 4 rows, in each row I will place 6 lamps. Okay. So based on the length, I will divide. I can divide. Of course, I can divide with 4 or 6. It depends on my thoughts. Okay. So somebody has unmuted himself. Okay. 30 by 6 is 5 and 20 by 4 is 5. Okay. Okay, so you can see here in this. Okay, you can see here in this room. There are around 4 rows are there. 4 rows are there, and each row you can see 6 lamps are there. And distance between each lamp is around 5 meters. Distance from one lamp to another lamp is around 5 meters. And the length, the room dimensions are 30 meters and 20 meters. 30 into 20 it is, you have already calculated, of course, you no need to multiply. The length of the room is 30 meters and width of the room is 20 meters. Okay. And just now you have calculated distance between the lamps. Okay. So throughout the length, distance from one lamp to another lamp, it should be 5 meters. And along the width, the distance between one lamp to another lamp, it is around 5 meters. Okay. So this is it. Did you complete this slide? Okay then. Draw this, all of you, draw this. Did you complete it? Just roughly draw it, okay? All of you roughly draw it. You draw it roughly. Did you complete drawing this? Roughly draw it. You just put some dots, that's all, for the lamps. In order to mention the lamps, you just put some dots. Did you complete? Shall I proceed? Yeah, okay. Okay, so similar to your previous problem, in this problem also we have a hall of 40 meters into 25 meters into 6 meters. The dimensions of the room are given, the length, breadth and height of the room are given. Okay, and here we are going, we have to use a metal filament gas filled lamps. Okay, to an average illumination of 90 lumens per meter square. The average illumination required is given. Okay, 19 lumens per meter square. Okay, okay, on the work plane, 1 meter above the floor. Okay, so you have to estimate a suitable number of lamps required. You have to estimate the size and mounting height of the lamps. Okay, you have to sketch the spacing layout. Of course, just now we have seen the layout in the previous problem. Similar to this layout, you have to sketch the layout, and you have coefficient of utilization is given, that is 0.5. Depreciation factor is 1.2. Space height ratio is given, that is 1.2. Okay, so size of the lamps are given here. They have given us three sizes. Three sizes are given here, that is 200 watts, 300 watts and 500 watts. And lumens per watt is also given, that is 16 for 200, 18 for 300 and 20 for 500 watts. Okay. Now similar to your previous problem, you have initially, first of all, you must calculate the area to be illuminated. So you know the length and breadth, you can calculate the area. So length is 40 and breadth is 25. So area is 1000 meters square. Okay. So illumination required, E is equal to, illumination required is also given, 90 lumens per meter square. Okay. Total lumens required is A into E. So A is what? Just now you have calculated, that is 1000 meters square. E is 90. So 1000 into 90. 90,000 you will get. 90,000 lumens. Okay. So did you complete that slide? If you complete, you just inform me so that I can proceed to the next slide. Did you complete? Type C if you have completed. Make it fast, Amma. Oh, very good. Okay, so it's similar to your previous problem, it is also there. Okay, so the lumens required. Okay, lumens required. So there is an issue with my system. Okay, of course. Okay. So the lumens required is what? A into E by utilization factor into maintenance factor. So here maintenance factor is not given in this problem. They have given depreciation factor. So 1 by depreciation factor you will write. Okay. So you know A into E. Just now you have calculated. Utilization factor also you know. Into 1 by depreciation factor. So you just solve this. You will get this value. You people can recheck the values by your calculator. Okay. So 90,000 by 0.5 into 1 by 1.2, you will get this. So lumen output per 200 watt lamp. So lumens per watt is given, that is 16. So for 200 watts lamp, 200, okay, wattage is 200. 200 into lumens per watt, just multiply it, you will get number of lumens. Okay, the required lumens, that is 3200 lumens. So lumen output per 300 watt lamp is 300 into 18. Okay, so these values are already given in the problem. So 318 for 216 for 520. Okay, so for 300, the lumen output for 300 watt lamp is 300 into 18, that is 5400 lumens. Lumen output for 500 watt lamp is 500 into 20. Okay, so 500 into 28 is 10,000 lumens you will get. Okay, so similar to your previous problem. So only the difference is there was a maintenance factor given in the previous problem. In this problem, only depreciation factor is given. And in that problem, they have given us only 2 wattages. Here we have 3 wattages. Okay, did you complete? Yeah, very good. Okay. Okay. So, I'm sorry, the slide has changed. It is not this slide. Yeah. Now, something is wrong. My system won't respond quickly. It's a old version system. So whenever I'm wearing the PPT, this is the first one. Next, where is second one? The third one. Yeah. Now for 200 watts lamp, the number of lamps required for 200 watts lamp is the total lumens required by the lumens required for this wattage. For 200 wattage, okay, how many lumens are required by total lumens required? I'm sorry, total lumens required by the lumens required for 200 watts is this. So you will get 67. So the number of lamps required for illuminating the room for the given dimensions, okay, for 400 meters into 25 meters, okay, this is the number, these are the number of lamps required. Next, the number, for 300 wattage lamps, okay, that for the wattage of means the power rating of the lamp is 300 watts. For 300 wattage lamp, the number of lamps required is total lumens required by the lumens required for this specific wattage, that is 300 wattage. So you will get 40 lamps. Okay, so for 500 lamps, 500 wattage lamps, the total lumens required is 21600, that you already know, divided by the lumens required for 500 wattage lamp. So the total number of lamps you have calculated. So the required number of lamps for 200 wattage is 67. For the number of lamps required for 300 wattage is 40, and the number of lamps required for 500 wattage is 22. Okay, the space height ratio is 1.2. Okay, so for this space height ratio, okay, so you can assume the number of rows and number of columns, okay, means in the lamps, the number of lamps required in rows and columns, okay, and you can multiply the number of rows with the number of columns, and that when you multiply the number of rows and columns, that must be equal to 67, and the space has the distance between the lamps must satisfy this space height ratio. Okay, similar to just for example, I have solved here for 500 wattage lamp. If I am taking 500 wattage lamp, okay, so actually I have only 22 lamps here. Okay, but for 22 lamps, I couldn't get the correct relation between the rows and columns. So what I had assumed is I have increased the number of lamps to 2 more lamps. Okay, actually I have only 22 lamps, but I am taking here 24 lamps. Okay, so it depends on me. Okay, it depends on me. If I see, even if a room is small, if I want to illuminate it, okay, if I want more illumination in even in a small room, I can fix more number of lamps than the room requires for illumination. Okay, so and so wattage room wattage lamps, number of lamps may be sufficient to illuminate a room, but I can increase the number of lamps required. I think once I have told you. So in my house, whenever I used to change my position of reading, okay, from one place to another place, I used to shift. Okay, my father used to fix a tube light there above my head. Okay, okay, so that's what my father used to do. In the same room, we used to have more than 4 lamps in the same room. Okay, but in order to illuminate that room, 2 lamps are more than sufficient. Okay, I'm talking about my house. Okay, 2 lamps were more than sufficient, but there were around 6 lamps in the same room. Okay, so hey, my father wanted to make sure that proper illumination was there on the work plane on which I used to study when I was in school. Okay, so that's what it depends. So here, actually, the number of lamps required to illuminate a room when I am using 500 watts lamps, wattage lamp is only 22. But in order to make it even, in order to get the required space height ratio of 1.2, I am using 24 lamps. Okay, so I have increased the value to 24 lamp. It doesn't matter. Okay, it's in our hands. That's what I have already told you in the previous problem. It is in your hands to decide what should be the number of lamps in the along the length, and how many number of lamps should be there along the width. Okay, but the space height ratio must be maintained. Okay, so if I am assuming 4 rows and 4 rows, and in each row, if I am assuming 6 lamps, okay, then I will get 24. Okay, I will get 24. So a length of my room is 40. So 40 by 6, I will get 6.67 meter, and 25 width of my room is 25. 25 by 4. Okay, this is 4. 25 by 4, I will get 6.25 meter. So the dimensions of my room will be somewhat like this. Okay, so the length of the room is 40 meters and width of the room is 25. So the spacing between the lamps along the length of 40 meters, the spacing between the lamps along the length of 40 meters, it is 6.67 meters. So in between the lamps, the distance between the lamps along the length is 6.67. The distance between the lamps along the width is 6.25. So if you see here, for 25, it is 6.25 meters. Okay, so did you complete this slide? So instead of, since these 200 watts and 300 watts lamps are not satisfying the 1:2 ratio, okay, that's why I'm preferring this. Okay, wow, I'm sorry, not 1:2, it is 1.2 ratio, space height ratio. Okay, that's why I'm preferring 500 watts lamp instead of 200 watts and 300 watts lamp. Okay, so whenever problems are given, you people first start with higher wattage lamps. Okay, later on you can go for lower wattage. If the higher wattage lamps are not satisfactory, then you go for lower wattage. So if you have observed in both the problems, I have considered the higher wattage lamp first. Okay, and I have seen if since it has satisfied the space height ratio of 1.2. Okay. Did you complete this slide? Okay, very good. So did you draw this? It is similar to your previous problem. Okay, you can write down 6.67 and 6.25. Okay, we have to solve few more problems actually. 4, 5, 6, three more problems are there. Okay, so I have to take attendance and I have to check your notes. That's why I'm stopping. If I was not I was not willing to check your notes, I might have continued this. Okay, I will stop here. Okay, I'll stop recording.